Hello, I'm John, and welcome back to Osaka Makerspace. So today we're going to continue our cat toy project that we're working on. I've gone ahead and sketched out a schematic off camera, just because I'm not the best person at drawing, especially schematics. Sometimes I forget the right symbols. Oops, that's okay. I didn't study this stuff in school. I just kind of self-taught. So, anyways, I double-checked even, and well, it's still not perfect. It's pretty good. And so here's what happens with our project here. So our circuit starts off here with the motor, and so as I believe I mentioned before, this is a motor from a printer, and I've run it up before on the power supply, and I've determined that somewhere between 7 and 9 volts will give this a very decent rotation that is fast but not too fast, and something that can actually be stopped by the cat while he's playing with the toy so that it doesn't like hurt him or anything, And if it does get stopped, then the amps on the motor don't go up so unbelievably high. This motor will actually go quite a bit higher than 7 or 9. So I think it's a very safe operating range with what we expect to have happen. So let's just go ahead real quick and kind of give it a test. Let's just see what goes on here. And so with motors, it doesn't really matter if you hook it up one way or the other, with a DC motor like this one anyway. And so this particular motor does have a little red marking on this leg. I don't know why. I guess it's just part of the the manufacturing process of the printer, to make sure that they put it in the right way around, because if you do swap the leads, the motor will just kind of go backwards, and so if your printer is running backwards, I suppose that's not going to be really good. So let's just go ahead and turn it on. This is going to be at 9 volts, since that's kind of what we determined on the schematic here. I have 7 and 9 volts. We might still go down to 7 if we can, or if we feel like it's necessary later on, due to the speed of the top of our contraption spinning around. So let's go ahead and turn this on real quick. Okay, so this is 9 volts, right? And this is drawing 0.037 amps, 376, yeah, between 0.037 and 8.6. It jumps around. Basically, this is 1/3 of a watt of power right now, and I'm a little bit not excited about grabbing this thing, just because it did give me a little bit of a cut the other day. But as you can see, you can stop it fairly easily. It's just a little bit sharp on this top part. You gotta be careful there. The bottom part seems okay. And so the cat, I think if he grabs it, it'll kind of slow it down. But we're gonna be running this thing in just short bursts anyway, right? But the idea is that if the cat has maybe got the string wrapped around him or something, and it activates, it's not going to hurt him, right? Because it can be stopped. And so that's really why I thought 7 volts might even be a little bit better. If we turn down our voltage here real quick, show you what I mean, because 9 is a little bit stronger, obviously. It would be. So again, our amps are about the same. This motor is even at 7 or 9 volts. Let me flip this around so I can write more easily here. This motor is drawing 0.03, between, even sometimes goes down to 4 to 0.03, as high as 8, but I haven't seen it go higher than 8 yet. Volts, right? Sorry, no, amps. Not volts, amps. And so that's how much amperage we're drawing on it. And it's at 7 volts. And of course that makes it a quarter of a watt, right? 0.25. is what it's currently sitting at, 0.24, 0.25 watts. So that's, I think, very good, and now it's very easy to stop with your hand, right? And when it's got the added weight of the little block and the cat toy and everything, and especially some leverage, I think it's going to be very easy to stop. It might be even too easy to stop, but when I hold it, for example, it jumps up to 2.6 watts. This is 0.376 amps of power that is drawing now because it's been stopped. It's under high load, so it seems like it's probably okay. And as I was saying before, it doesn't really matter which way these are connected. We're just going to get different rotation. So now it's running back around the other way, but the draw is the same, right? Now it's running this direction, but it's still 0.37 amps, 0.25 watts. So it doesn't really matter which way you have it connected. Let's go ahead and turn that back off for now. Okay, so what we want to do first, let's talk a little bit more about our schematic, I guess, first. And I'm going to use my knife here. It's a good pointing device, I think. Okay, so plus, minus. Here's our positive 7 to 9 volts, depending on what we think we need. We want to definitely keep it safe for the cat. And ground, and they're just connected direct, right? So we have a couple other things going on here, kind of in between. I guess this is not exactly direct, but ground and negative, right? It's still all kind of connected. So here we have a diode. As I explained before, this is our diode. This is going to prevent, as the motor continues to spin, even though the power is cut to it, just simply because of inertia, then it will allow the power that's generated by the motor, because motors are things that can take electricity and create motion, or they are things that can take motion and create electricity, right? They work the same way. It's just a coil of copper that is either exciting or being excited by a magnet that is in motion. So we have this diode to keep our power from flying back into our transistor here and possibly destroying it, right? Okay, and then here we have a capacitor. This is here's something I would like to talk about real quick, because this is something that when I first started studying electronics really confused me. And for those of you out there who might be watching who already know about electronics, then you're probably thinking, well, of course, that's dumb. Everybody knows that. But actually, no, not everybody does know this. When you hear things like pull-up resistor or a pull-down resistor, or you hear something like a filtering capacitor, or things like this, these are not a special kind of resistor. A resistor is a resistor, and it doesn't matter which way you've put it into the circuit, right? For a resistor, there's no polarity. There's no plus, there's no minus. And there aren't specific, oh, this is a pull-up, and this one is a pull-down, and they're different colors, and they're made different ways. No. What that is you're describing the job that the component is doing, right? So a pull-up resistor is going to be attached in your circuit in a way such that the resistor is causing the voltage to be pulled high, to be pulled up from ground. All right, so that's what that means when you hear pull up, pull down. It's not a specific type of resistor that you're trying to find. It's describing the job that it's doing. And so this is a filtering capacitor. It's not a special capacitor. It's a capacitor that's being used as a filtering device. Okay, so this is just a normal ceramic capacitor 104, and it's being used in a way such that it filters out noise that will be created by the motor. Okay, so that's what we mean when we say this is a filtering capacitor. So when the motor spins, and especially when the electricity is cut off, this can cause the motor to kind of jerk around, or as it is turned on, it can cause the motor to kind of jerk around a little bit. And sometimes that's not a big deal. And for this project, indeed, it may not be a big deal simply because we'll be using small bursts of electricity. But if you do want it to spin for a longer amount of time uninterrupted, then something like a filtering capacitor, especially when being driven by a microcontroller, such as this will be, then it will provide a lot of stability to the motion. So I do recommend using a filtering capacitor. So that's why we have these two things here, and they are just connected basically across the connections of your motor. So if we were to connect them like this, then you could solder it directly across the ends, and it could be sitting on the side. You wouldn't want to short it out, but it could be happening. And then same thing here, your diode can just be soldered directly across, basically, right? So when you see things like this in a schematic, it's true that they are all connected in the same spot, but we often kind of, physical components need space of their own, and so we often will connect them using wires or lines on your PCB, but they are all just basically touching. So then here we have our NPN. This is, in this situation, it's a 2N2222A transistor, and the base is connected to our Digispark here via pin 1 is the pin that I'm going to use here, because it's PWM, which is a let me make sure I get this right, pulse width modulation. I believe that's correct, and basically that's the duty cycle, right? The thing that allows you to manipulate the duty cycle. And so pin 1 is not the only PWM pin on a Digispark. Pin 0 is also, as well as pin 4. But those pins are also, they have a lot of other uses, whereas pin 1 is basically PWM, and then looks like it says DD. Not exactly sure what that is right off the top of my head, but I don't think it's something that we're going to need. So just to kind of preserve future utility, upgradability, we'll leave those more useful pins open, and we will use pin 1 for this. And then the other end of our transistor is going to ground. So the way that this transistor is functioning is that when the microcontroller sends the signal to the transistor and through the base, and then it tells it to allow electricity to flow from the collector to the emitter. And so that's basically telling it to connect the motor to ground, right? When there's no power coming from the microcontroller, then it is not connected to ground. It is disconnected. The circuit is not it's not complete, and there's no power going through the motor. So that's basically what we're doing here. So let's go ahead and solder this up real quick so we can try to get started on our breadboarding. So these Digisparks are not exactly made for breadboarding. They're made to be small and to be easily programmed via this USB interface that's already printed onto the board. So what we're going to do is we're going to try and give different pins on the top and different pins on the bottom. So let's go pull 3 of these off and solder that on. Let's get my soldering iron hot again. So I think what we'll do, I think we're going to go up on our power pins and down on our interface pins like this, right? And then we will simply connect these power pins using our jumper wires like these, and similarly we'll attach to the interface pins, the I/O pins, but we'll do it in a slightly different way. It'll make a lot of sense very soon. So let's go ahead and solder this up. Okay. it's dirty. Always clean your soldering iron before soldering. Wow, that was a mess. That's all right. That's okay. All right. Since those are sticking up, it doesn't really matter if they're square with anything or not, because we're going to be using female connectors to connect those. But we do want our other pins to fit in a way that they will go into the breadboard properly. So what we're going to do is we're going to go ahead and push this into our breadboard just a little bit. It doesn't have to go all the way in. It kind of went most of the way in, but it's not important that it goes all the way in. You just kind of want it to stay square. And go ahead and start on these. So especially if you are soldering into a breadboard like this, be sure not to hold your soldering iron to any pin for too long, or you will start to melt the breadboard underneath as the heat travels down the pin. So just to kind of reduce the likeliness of melting my breadboard, I'll solder the first and the last pin, and then I'll take it off of the breadboard and finish soldering. But those two will keep us right on track. So you can hear Ryan has come in and is now watching the show. That looks alright. Not too bad. People don't tend to like the non-lead solder, but really I don't have any problem with it. I think it works pretty well. I guess I was never spoiled by having leaded solder, I guess, so yeah, I'm alright with it. Okay, that looks pretty good. So, how are we on time here? Well, we're running a little low on time, but that's okay. We will we'll try to get our circuit completed anyway, and then we'll have a look at its operation next time. So, what we want to do first, we're only using one of these pins at the moment, so it doesn't really matter how we attach it. But as you'll see, this is why I wanted to attach it in this way. This allows us to have each of our I/O pins accessible for the breadboard, and then it also allows us to easily connect things to our power and our power pins there. I might even move it over one more just so I have a little bit more space because of our USB port here. There we go. So let's see if I can find all the right wires here. Now when I do breadboarding, I'm not really all that bothered by what color I'm using, just because I'm looking at it anyway and trying to always read it, keep track of what's going on. So I don't always do red and black for positive and negative. If that's a problem for you, I'm sorry. I'll try to accommodate you here, but it may not be a reasonable expectation, I'm afraid. Let's see. I got a nice big zip bag full of random jump wires here. A nice big mess. But yep. This is not looking like it's gonna be a doable thing. Ah, wait, I do have some over here. Okay, there we go. Just for all those people out there who are driven crazy by things such as this. Although there are probably other people out there who are being driven crazy by my pulling apart these long, nice ribbons to get individual colors, but You can't please everyone all the time. Okay. There we go. So that's rather convenient. I like having these female male wires. Okay, there we go. Now we're connected. All the right colors. But are we really going to keep all the same colors all the way around? Maybe we're not. I'll try, but maybe we're not. Oh, have a look at this wire. This is a recycling job here. We had a customer come into the makerspace, and I think he didn't really care that these wires are expensive, and he just wanted some wire, and so they were his. He bought them. I mean, I have all these wires that I'm using here. These are mine. They're for the makerspace, but these are some wires that he brought in himself, and so he just started cutting the ends off of his jump wires, just so that he would have a length of wire that he could then solder. And I thought, oh my God, that's the worst. So I collected his little clippings and just connected them to some random wire and heat shrink around them. So yes, now we have some extra wires. But so anyways, where were we here? Alright, so we need to connect our motor. And so actually, I have some alligator clips here. Oh, and I do have a red one. Alright, so let's go ahead and do that. Okay, and then we'll have to, since my alligator clip is just going to have to be connected like that. Okay, and let's just go any random spot for now. Actually, since this is going directly, we might as well go ahead and connect it like this. Connect it to our positive, straight to the ground, to the positive rail. There's no reason for it to be anywhere else. And do I have, yes, I do have a black one as well. Okay, alligator clips are also a little bit expensive, although I think they're not quite as expensive as these breadboarding wires. And you can make them yourself as well. I'm looking for the black wire. There we go. Okay, to the other side of the motor. However, now we're going to have to hook this not directly into ground, because then we'll be bypassing too much. So let's just set this to the side for now. And what we need to do first, I believe, is deal with our diode and our filtering capacitor. So since these already have nice long legs, we can just, well, we could do a couple different things. We could connect them in such a way as something along this line, right? But really, there's not a big need to do that. It's basically just going to go back straight into positive anyway. So what we can do, just to save a little space and a little time, and a few wires, is just connect straight up into our power rail. Now make sure that your diode is facing the correct direction, because diodes do have polarity. They have a positive and a negative. And the side with the little silver stripe is our positive side. So that's what we want going back into. So that's the direction that the power is allowed to flow through a diode, right? It goes always towards that silver stripe. So we want that connecting straight up into our positive there. And basically the same thing going on here with our filtering capacitor. We can just hook right into that same spot. Well, this might be a little bit hard, but I can always just get a little closer. There we go. That should do it. Now we're going to need, in this same spot, we're going to have to connect to our transistor. And this is going to go through the collector. And let's see, I don't exactly remember which side is which. One moment. Okay, so since I don't remember which leg is the collector and which is the emitter, we're just going to test it real quick. So we'll throw this right into our component tester here. We could also look it up online, but then that pulls me away from the camera for a little longer than I would like, and it's just boring Googling, whereas if we do it this way, we actually get to do some stuff. Okay, testing. And so the first leg is the collector, and the third leg is the emitter. Let's just go ahead and jot that down. 1, 2, 3. Collector, base, emitter. Okay. Now, that's good. Take that out. Turns itself off. Excellent. Yeah, I love this little thing. And it only needs 5 volts, but it has a 9-volt connector, and so you can really run a 9-volt battery down. It's great. This battery is currently running at 5.1 volts, and it's more than enough to keep this thing running. So that's really cool. Okay, so if I remember correctly, and I perhaps do not, when you look at the flat side of a transistor, I believe, and if I'm wrong here, there will be maybe some text popping up over here, maybe in this area, telling you the correct numbers. I believe the one on the left is leg 1. So that will be our collector. Editing opportunity right now. Okay, quick correction. I did have that backwards, and I've swapped it around here in the breadboard already, and I've also drawn this little correction here just so I can help keep myself clear in the future. So with the flat side, facing the flat side, the pin number 1 is on your right side. That is the collector for the 2N2222A. So make sure that you have it correctly oriented in your circuit, and yes, let's try to remember these things. Speaking for myself. All right. Okay, so let's try this out. Collector is going to come from the motor, and so we're going in this type of a situation here, if I'm not wrong. If I'm wrong, we'll find out when we turn it on. Okay, and so this end of the motor also going to go right here, I believe. Boy oh boy, if there's a cut at any time in this video before now, it's because I made a mistake. And if I did, you won't really know, because I won't have said this, because it'll all be cut. But if I didn't, then you'll know that I wasn't sure, and that's okay. You don't have to be sure. You just gotta try. Okay, and then so we have the let's see, we have to connect this to ground, because we're currently not grounded. So there we go. That one is a really long wire, but options. Aha, here's one. That'll be better. Keep it cleaner. Okay. So this jumper wire here is this section here. Where's my knife here? It's a little bit better. There we go. This jumper wire is this section here, from ground to the emitter on our transistor, and then here this section goes to our motor, right? But also connects to both our capacitor and our diode, and those then in turn dump directly into the positive, as you see here and here. And then we also have our motor connected to positive, and it goes here. Now what I don't have written here on our schematic is that we also have to connect to positive and negative, right, on our microcontroller, of course. And so here we've already done that. So now all we have left is to connect to pin 1 with our resistor, and that is going to go over to the middle leg, our base on our transistor. And since I don't have quite enough room, what I can do, let's move this. It doesn't have to be right there. There's no need for it to be. Let's move this over here. We will stick it so that pin 1 is lining up with our transistor. Close enough. That's close enough. It's not exactly, it's actually lined up with pin 0, but okay, so maybe just in case you don't know this, some of you may not, in a breadboard, this line through the middle, this ditch, is actually dividing the entire breadboard. Things that happen over here do not affect things that happen over here. Okay, so I do recommend you just Google real quick, see how a breadboard is set up. It's very interesting and it's very simple. So we'll plug into pin 1 and plug into our base. Yeah, that's great. Now our resistor wire is a little bit long, but that's okay. You can trim it down, but I think it's alright. It looks good. Okay, so that is our circuit mocked up, at least the motor anyway, and the microcontroller. So we still have to connect our sensors, but we'll do that next time. And we'll also write a little bit of code for testing out our motor, just getting it to turn on and off, something like that. Should be easy. And then we'll also have to start finding what we want to do for our power supply. So that's it for now. This video is a little bit longer just because we had lots to do. But I hope you've enjoyed it, and I'll see you next time. Bye.